Good morning. Good morning. Good morning. Good morning, Edison. There, you can hear me now, right? All righty. How are we doing with people? How many people? We got a few more people yet to go. I will wait a couple of more minutes here. Well, I'm going to start and I'm going to show you a few things. I went on the AP website on Friday. Let's see if I can find it. Oh my gosh, look at all this. So I'm hoping you could, I'm hoping you could see this. So this is the time you'll be taking the test. It'll be at 1 o'clock on May 12th. You will have 2 questions and you'll have 25 minutes to read and respond to question number 1. And then you'll have 5 minutes to upload your response. After uploading the response to question 1, you'll have 15 minutes to respond to question 2, with an additional 5 minutes to upload your response to question 2. Once their response to question 1 has been submitted, you cannot go back. So you about have 25 minutes to figure out question 1 and 15 minutes to figure out question 2. Can you see this okay, Madeline? Do you see this? All right. Then the other one I have is this. And so what are the questions like? They're both called multi-focus response questions. I wonder if you guys can even see this. Are you able to see this?
No.
Yeah? Okay.
No,
See it again?
I can't see it.
Okay, well maybe I gotta, oh, I see why. All right, let me share screen again and let me get, I think it's this one. Can you see this now? I think so. So this is, they're both multi-focus, which means there's parts A, B, and C, probably D. And so the questions will assess student knowledge and skills developed in 2 or more eligible units and topics. Question 1 will consist of similar components to traditional AP calculus exam questions with minor modifications to enable students to choose to submit with either typed or handwritten responses. And question 2 is the same type of thing. Now, this is what's going to cover units 1 through 7. Basically, it's everything we've covered except what unit 8 is, which is area between two curves, volume by cross sections, and volumes by revolution. So we hadn't talked about volumes of revolution. That was the lemon activity we were going to do. So that gives you some information. And I will send the link to where I got this information. Okay. But again, it's looks like May 12th at 1 p.m. I'm assuming you guys will get some type of email. I'm hoping so. Any questions on that at all? Any questions and anything you've done so far? Remember that you have an AP question to submit this Thursday. I'll be giving you another one. I've already put it on the assignment sheet. And I think I attached it. I'll make sure, if I haven't, I'll edit it and make sure it's attachment. And you'll see it'll be over what I'm going to go over today. Okay? All right. I like it when you nod, because I would just like to see everybody. I would just like to hear everybody. All right, I'm going to share another screen, and here's the problem I'm going to look at. All right. And it's right here, I think. Oops, that's not what I want. Sorry. What did I just do? All righty, let's try to do this again. I think this is what I want. All right, let's see if that's, I don't want this. I'm going to call up what I want here. Okay. And so you're going to need a calculator. And so this is from 2018. And again, it's a problem that you see quite often. They have a particle moving along the axes. In this case, it's moving along the x-axis. And you have a velocity function. And so that's the function I'm going to end up putting in my calculator. So I'll grab a calculator here. And I'll share that calculator with you. Oh, maybe I won't. What is your problem today, calculator? Try this one. Okay, I think this will work. All right, I'm going to share this calculator with you. And since I was TI last time, I'm going to do Casio today. And so I'm going to enter this function that I have. And that's going to be parentheses 10, the sine, 0.4 x squared divided by parentheses x squared minus x plus 3. And that looks correct. And I'm going to set my window. Next is going to go from 0 to 3.5. And I don't know what my y is. I'm going to go from -10 to 10 just to see what it looks like. And I'm going to draw it. Okay, so here's my graph right here. And I'm going to change the window slightly to not make it so, I'm going to make it pretty smaller. Let's go from -3 to 3 and see what that looks like. Yeah, I like that better. Alrighty, that gives me a bigger. Okay, so now I'm going to stop sharing. I'm going to go back and share again. This is driving me nuts. And I'm going to go back to the problem. And so there's my problem. And the first question is, find the acceleration of the particle at t = 3. Oh, it also tells you this. So on the x-axis, remember that particle's moving along the x-axis. At time 0, it's at a -5. So think of a number line. I get my sketchbook working here. See if it works now. Okay. So think of a number line here. Here's a -5. So that's where it is right here. Here's 0. So my question is, this first one is find the acceleration of the particle at time equals 3. Any ideas of what to do?
Could we just plug the 3 in?
Into the function?
Yeah.
Okay, what does this function compute for you?
Oh, never mind. That's velocity. I didn't see
Yep.
that part.
So what do you think we should do?
Take the derivative of it.
Yeah, so this is what I would show for my work, Adam, is I would say the derivative of velocity is equal to acceleration. And that means the acceleration of 3 equals, you're going to come up with some number, correct?
Correct.
All right, so what I'm going to do now is I'm going to go to my calculator. And I'm going to go to, so if you're a TI, you're going to go to math. On the Casio, I'm going to go to options. I'm going to go to calc, and I'm going to take the derivative. And what am I going to take the derivative of? I have to go to vars and get y1. So if you're on a TI, you're going to go to math. Adam, I think it's math 8. Am I correct?
I have a Casio.
Oh, okay.
You're right. It's math 8 and derivative.
Right. So you go to n derivative, math 8. Then you put in vars 1, correct? If you're, this is a TI. And then you got to put comma x, then comma 3. Am I right with that, Landry? I think the Casio, you just have to go derivative, vars, or you get y1, and then you just put a comma and then 3. I think you skip the x part. And so that's the acceleration I get. We okay with that?
Mr. Kruger,
Yes.
if you wanted to find the derivative, not necessarily like at a specific x value, could you do that? Like, is there a way to just type like to get the derivative of the function?
Yeah, I see. This is how I would do that. That's a great question. So what I would do is I would go back to my graph and I would go to y2. All right. And then I'd go to, for you again, it'd be math 8. Over here on a Casio, I'm going to go to options and I'm going to get my, go to options and get my derivative. And so for you to get math 8, you're going to get num deriv. And then I'm going to put in of vars again. And I'm hoping this is answering your question. And then over here, rather than put the number 3, I'm going to put the variable x in there.
Okay.
Okay. So now what that will do is I can graph what the derivative looks like if you choose. I'm going to get rid of this y1. Okay. And so now I'm going to draw, and all I did was highlight, make sure this highlights off, and I draw this. And so what I can do now is trace and go to 3. This is how I could do it on a TI. And it'll tell me what that value is, which is a negative 2.118. Okay, does that make sense?
Yes, thank you.
Okay. Adam, since you have a Casio, you wouldn't have to do that. I got to ask you, Adam, if your Casio does this. So if I select this and draw that, and then go to trace and type in 3, will it give you, oh, let me go up here to mode. Can I go to shift setup? Yeah, if I come down here and turn my derivative on.
Yeah, it will give us negative 2.118.
Yeah. So you can skip that part of just graphing the derivative, since it will give you the derivative right there on that original graph, as long as you go to your setup and turn the derivative on. Okay.
Right.
Okay. And Josh, you're okay with my explanation?
Yes, thank you. That helped out
Okay.
a lot.
Yeah, and another thing you could do, Adam, is rather on the graph, you could go to just put in y2 comma 3, and it'll also give you the derivative, but it allows you to get the derivative at any point then. Okay.
Okay.
All right. Let's go back to the other problem. Okay, so now we're back here. And of course, I didn't write it down. It will, what was it, a negative 2 point something?
Negative 2.118.
Okay. And it doesn't give me any units, so I don't have to do any units. Okay, so notice in this question, they give you a function and they have you take the derivative. Now, if I look at the part B, it says, find the position of the particle at time t equals 3. I know it started at a negative 5, correct? And I know that it has moved since then. So how do I figure, if I know it started at a negative 5, because at this line right here, it says the position at time equals 0 is a negative 5. How do I figure out what position it's in now? Am I going to take a derivative?
No.
Antiderivative.
You're not going to take the derivative,
Kruger,
right?
would you take the integral from 0 to 3
Of what?
of v of t, and then add that to negative 5 or minus 5 from that?
Right. So that's exactly what you're going to do. You're going to take the derivative and add a negative 5 or subtract 5. It's the same computational part. So notice how I'm showing my work here. This first line is how I show my work. This next line is how I show this work. So again, this is where I'm starting. This is how much I moved, how much my net is. So now my calculator can do that work. And again, I'm going to go back to my calculator. And I'm going to go to my menu. And maybe I can use my screen. I just have to make sure I turn this thing off. Oh, it is off. Okay. And so what I'm going to do now is I'm going to, on the Casco, go Shift G solve. And I'm going to figure out the integral. For the TI people, it's going to be second calc. And you're going to integrate. And so I'm going to type in 0. And then I'm going to type in 3. It's going to shade that in. Now notice, this is my velocity function. And right here, my velocity function touches the axis, doesn't it? So this means that my particle started at -5, went to this distance underneath this curve, stopped and turned around. Okay, this might be something on a later question. So I have 3.23, well, it's going to be 3.24, it looks like to me. So that's how far it moved, but it started at a -5, correct? So let's see, go back to our problem. What's our answer going to be?
Negative 1.76.
Okay, so the reason I brought this up is look, you know how when I described what kind of questions you're going to get, it's going to have multiple phases. I don't know if that's the word they used, but the first part, A, you're taking the derivative, and the second part, you're doing the opposite. You're taking the integral. Okay, so that's how they're going to be going back and forth. All right, so let's take a look at this. It says evaluate this integral and evaluate the absolute value of the integral. Interpret the meaning in the context of the problem. Well, the only difference between the two is that one has an absolute value of the velocity and the other one doesn't. So how are they different? What do you get when you take the absolute value of the velocity? And how is that different than not taking the absolute value of the velocity?
The absolute value gives you the total distance traveled, and then the regular velocity gives you like the total distance traveled in a certain direction.
Right. Well, so this, I agree. This is going to be my total distance traveled. So when we compute this number, we will say that is the total distance that the particle moved. This is going to be the net distance. So in other words, if I take 4 steps to the right and 3 steps to the left, my total is 7 steps, but my net distance is 1 step. So this includes the turning around and how far you walked back. So I'm going to show you the calculator, show you the difference, and calculate them out. And so what I'm going to do on this Y2 is I'm going to delete it. And what I'm going to do in here is, for TI people, you would go to math and go to NUM, math, and then NUM. And at the very top on line 1 should say absolute value. Here, if we go to options, I think we're going to have to go to numeric, and there's my absolute value. And what I'm going to do is I'm going to go back to vars and get Y1 and put it in there. And the reason I don't do that is I don't have to retype everything. Okay, so again, I'm going to deselect Y2 and just graph Y1. And again, I'm going to figure out the integral. I suppose I'm going way too fast for everybody. I'm going to go 3.5. And so you can see it's got this portion underneath here. And so this is going to be my net area, or what they call my displacement. So when I write this down, I'm going to write 2.844. That is the particle's displacement. That's how I will answer that. Again, this 2.844 is my particle displacement. So now I'm going to exit. I'm going to come up here. I'm going to press enter. Oops, I'm not going to. I'm going to hit select. I'm going to come up here and I'm going to deselect the first one. And I think what you do on a TI, you just get over the equal sign and press enter, and I think it turns it on and off, I think. And so now when I draw it, that portion that was underneath the x-axis will be above it. You can see that it bounced up. So you have all positive values. So now when I calculate this, I should have more. And I'm going to go again from 0 to 3.5. And so this 3.737 is my total distance. Now I'm going to go back to the problem. So when I write this, I'm going to say the integral from 0 to 3.5 b of t dt equals 2.844 is the particle's displacement. And the integral from 0 to 3.5 of the absolute value of v of t which was 3.733, is the total distance the particle traveled from 0, 3.5. Right here, I wonder if I should say 2.84 is the particle's displacement during, again, say the interval. And I don't think it matters if they're open and closed, so I don't get hung up on that. I'm going to try to do D here. It says the second particle moved along the x-axis with the position given by t squared minus t. For what time are the two particles moving with the same velocity? So how do I figure that out? And this, by the way, is not a velocity function. It says right here, the position is given by, and they love given the position. They use this X here to stand for the position on the x-axis. And they put the 2 here telling you that's the second particle. And when they talk about, if this would be velocity, there'd be a V here. So how do I figure out when the velocities, when they're moving with the same velocity? Sound of silence.
You just take the derivative of x of 2t, and then
Is it an easy velocity to figure out?
yeah,
What is it?
2t minus 1.
Okay, so I know that. So what do you think I should do with it now?
Plug that into your y2 and then find where they intersect.
That's exactly correct. So that's what I'm going to do. It was 2x minus 1, correct? Oops, forgot to turn the other one on. So it looks like there's one time that they have the same velocity. So again, you can go to TI, you go to second calc and look for that intersection, be a little bit to the left, a little bit to the right. Here, we're just going to go Shift G solve. We're going to look at the intersection. And it's going to tell us the time is 1.571. And its velocity at that time, both of their velocities are 2.141. So I'm just going to write that down. And so the way I would show this is I would say, yeah, I would say this, V of T one equals V of T two at T equals 1.571 with a velocity of 2.141. Okay. All right, so what I'll do is I'll probably give you another example. I've assigned this and it's not due till the following Thursday. Remember, we don't meet this Friday and we don't meet next Monday because you guys need, because we're following the calendar. Okay. I have to get ready for my next class, which is in 6 minutes. I'll answer any questions that you have. You can send them to me if you need to. I don't know if there were any questions on the chat. It doesn't look like. So don't forget to send me any questions as you work through these. Okay? You guys have a good day.
You too.